Hello and welcome to this episode of Build Your Autocad IQ. On this edition of the Third Dimension, we are excited to be talking to you guys about laser cutting. And for laser cutting, the great thing is you can create your 3D objects using 2D line work, which means anyone using AutoCAD LT can follow along here. We're super excited to be inclusive of those LT users because very often we find that it's not something that they can use in a lot of these Third Dimension series. So if you guys joined us a few months back, you would have remembered that we did 3D printing. Just like 3D printing, there are laser cutting services if you don't have direct access to a laser cutter, but still want to bring your creations to life. We got the local maker spaces, and also there's something called Ponoko that you guys can check out. And if ever you're in the Boston area, over here at 23 Dry Dock Ave in Boston, we have the build space where with just a couple of classes, you can use the laser cutters and 3D printers that we have here as well. The cool thing about this whole thing is that it is another opportunity to go from the digital to the tangible. And it's also a great method for testing out our models with having to avoid using very expensive materials. We can do a lot of these laser cuts and etching on even cardboard, which is something that we'll get to you later on in the webinar. We're going to be going over a whole lot of things here, so I guess let's just get going. My name is Alex. I'm a technical support specialist here located at the Boston office. I'm going to be joined today by Victoria. She's also a technical support specialist. She's based out of our Manchester office, and we are also joined by Naman, our expert elite. And if you notice something a little different about this slide, yes, those are laser engraved images of the three of us. We took some high definition images and put them through our laser cutter and made these. It was pretty cool. So for today's agenda, we are going to be talking about prepping our AutoCAD files. And again, everything is going to be two-dimensional. And then we're going to be kind of thinking ahead as to what we're going to be doing in terms of going from that 2D to the 3D. So we'll be talking about that in CAD. We're going to be going over the actual configuration of the laser cutter. Once we've created our models, there is some parameters that we have to adjust before we actually start cutting and etching and doing whatever. And then lastly, we'll be going to the laser cutter. And also I just want to point out again that everything we did for laser cutting was done here at the Autodesk build space. So it's open. Anyone's welcome to come take a look at it. We got all these bay doors that are right there on the first floor. So if you're ever in the area, you could just definitely walk by and maybe see some robots playing around and some other cool things going on. So I think we should really get going into this. So I'm going to pass it over to Victoria, and we are going to see this in CAD.
Thanks, Alex. Let me just take control of the screen here, and I will show you guys what's going on. All right, let's see. We'll get our AutoCAD up. Can you see my screen? Excellent. All right. I got a thumbs up from Alex over here. You can see my screen. And I know what you're thinking. These look like 3D objects, and we promised 2D line work. We will get there. These are the chess set that we designed in 3D in the previous webinars. So just to give you a little recap of what we've done, I'll zoom out here and show you the realistic view here. Here's our 3D chess set and board. Here are all those 3D printed chess pieces, and then over here on the left now we have our laser cut chess set. I just want to show you the final product before we dive right in. Alright, so back into our working file here. I'm going to zoom out a little bit so that you can see the original line work that we started with at the very beginning of this journey back in May or June, I believe. So here we have the profiles of each one of our chess pieces in the set: the pawn, the rook, the bishop, the knight, the queen, and the king. So the first thing that you need to know about laser cutting is that even though you're working with 2D geometry, you need to be thinking in 3D from the very beginning. And we'll be showing you a couple of areas along the way where we probably should have thought a little bit farther ahead. But that being said, I'll try to set you up for success here and walk you through the process. So the first thing that I want to note is that the material that you're going to be printing on is important with this particular exercise. So when we're designing these pieces, they're going to wedge together, and we're going to cut some notches into each one of them. So there's two pieces of wood that need to slide together in order to stand up straight on the table and create a single piece. And the notches that we cut into these pieces need to be the thickness of the material that you're printing on. So let's use the pawn as an example to start with. I have my half profile here, and the first thing I can do with this is use the mirror command. So MI for mirror, or you can type the whole thing out if you'd prefer. Enter, and grab that top point there, and then mirror it here. And you want to keep both sides. So this seems pretty straightforward. It looks like the right shape. I've left this little notch in the bottom to make this drawing process a little quicker. You can always trim this later. From here, I'm just going to use my PL, polyline command, and start with this point, and I'm going to draw up 3/4 of an inch. And then if my thickness of my material, the wood that I'm printing on, is 1/8 inch thick, I'm going to draw that 1/8 inch notch over and then draw this back down. Now this does not need to be a closed polyline. You probably want to keep them all on the same layer just to make sure that if you do decide to use color mapping in order to print with custom print settings to your laser cutter, that you can do that easily. But it's not necessary, at least not for the laser cutter that we were using. We were using an Epilog Fusion M240, just for reference here. There are the whole myriad of laser cutters on the market, but that was the particular one that we had available for us. So the presentation will be colored that way, but we tried to make this as generic as possible so that you can apply this to any laser cutter. All right, so from here, I'm just going to use my match properties command, match prop, and put this on the same layer. There we go. So the second thing I want to do is create that second pawn profile. So I'm going to use my CO, copy command, pick a base point, and drag this off to the side. So now I have two copies, but if I print out both of these, they're both the same exact profile, and they won't notch together properly. So what we really want to do here is mirror this. So I'm going to use my mirror command again and mirror this up, and this time I can choose yes, delete the source object, and this mirrors that up so that these two notches will line up perfectly. They'll notch together and the pieces will sit flat together on the table. I'll use my TR, trim command, and just trim that excess geometry out of here. Let's zoom in on it for you. There we go. Okay. And then, as I said, these don't actually matter if they line up here for the laser cut. As long as it's a continuous line, it will cut it. All right, so now I have my two pieces, and let me show you exactly what's going on here. We'll go back into our 3D model and switch into a hidden view, hidden visual style, I mean. All right, so if we look at that, these two pieces are notched together, so if I move this off to the side here, you can see exactly what's going on. They slide together just like that. And then for those of you who joined us for the view base presentation a few weeks ago, here's a view base done on the rook, or sorry, the bishop, for example. And this shows that front view and side views, a couple of isometrics, and a top view of what this piece looks like if you were to document it for production purposes. We'll save these all in the box folder too, so you can download them and investigate them to your heart's desire. Okay, so now back in the file here. So we'll go over and so this one will work about the same way. You'd mirror it, you'd add in your notch. With the bishop, let's just note a couple of differences for each of these pieces. With the bishop, you want to be careful of that notch in one direction, but it doesn't really matter in the secondary direction. So when you go to cut your notches, you probably want to cut the bottom notch on the piece with that slice cut out of it on the top, and then cut your top notch on the one that doesn't have that so that you're not interfering with your geometry. Planning ahead like that can save you a lot of pieces cut off and you know, beheaded chess pieces. With your knight, you really only need that horse's profile in one direction. So what I did here was I cut off most of the geometry of the top of this piece and then threw an arc in here to cap it off nicely. The same thing with the king. Maybe you just need that cross in one direction. Maybe you need it in both. It's a style choice at that point. All right, so that's about it for the profiles. Now let's jump over here and I'll show you what that looks like. Well, let's zoom out for a second. All right, there are a couple of commands that you might find handy when working with the laser cutter. And the first one is limits. So if you set your limits to the extent of your, to the size of your print bed, it will keep you from working outside of the limits of that area and overshooting the size of your laser cutter. So limits, you can turn it on and off, and had a funny moment before the presentation where I panicked a little bit because I couldn't draw off to the side where I was showing you those profiles. It turned out that I have my limits set on and I couldn't draw anywhere but inside that print area, which again is a great safeguard if you only want to be working in a realistically printable area. So limits, you can set, you know, my bottom corner there is 0, 0, so I'm going to hit enter to accept the default. And then I know that the epilogue's print bed area is 42 by 28 inches, so I've set that already at 3'6" by 2'6". In an imperial size drawing, you could set your units if your laser cutter happens to work in metric units. You could set that up ahead of time as well. So you can toggle it on and off, and I'll show you what I mean. If I turn this back on and I go to draw line, it won't let me draw anywhere out here as I click, but it will let me draw inside the limits. So I'm going to turn that off for now. The other one, and you'll notice that I like this because it's a nice visual cue. Your grid display command controls the display of your grid. If you set this to 2, well, there are a couple of different options here. I believe you can also set this to 0. Where are we? Grid display. I'll just show it to you right there. Get that help file open. The initial value is 3, and that's going to show your grid forever. I usually set this to either 0, true, 2 also works, but setting it to 0 will ensure that that grid area only displays within the limits that are set. And I like that as a nice visual cue to tell me that you know, that I've reached the extents of the bed. And I mean, you might even turn the limits off and still have that visual cue, but then you can still draft some of your modeling off to the side and then move it on to that print bed area just with the visual cue of the grid. It's a workflow choice, but I wanted to make you guys aware of that particular system variable because it comes in handy if you're a very visual thinker. Let's see, what else did I have here? Oh, right. So we have, so I've set this, we had a 12 by 12 piece of wood, so I set this up, I think I set it up as 9 by 9 just to be safe. I didn't want to get too close to the edge of the board. We were playing it cautious because we hadn't used this printer before. Probably could have gone right to the edge. It was actually very precise, the laser cutter. So we could have filled up this whole 12 by 12 piece of wood that we got. But again, if you want to err on the safe side, just set yourself some limits there. This here actually cut out a whole piece for us. And what you can do with some laser cutters is to set up a, an internal vector cut and an external vector cut. And what that does is it'll cut out all the pieces on the inside first. It'll make those interior cuts, and then it'll make that exterior cut last to cut the whole piece out. You can set that up to do vice versa. It depends on what you're printing. For the board, we wanted to do something a little bit different. What we want to do is etch the odd squares and leave the even squares alone. So in order to do that, you can use hatch instead of vector lines. And the hatch gets read as an area to be etched or engraved. So, or rather, not engraved, etched. So, a couple of important things to note here. Let me freeze my hatch layer first, and I'll show you how I set this up. I created these sketch lines here, and they're set at 1-inch intervals. This was just put in place so that I could add that hatch very quickly by picking the internal points. But if you leave these on and then you send this to the printer, the laser cutter will cut your board into 64 different little pieces. So unless you want to put your board together as a puzzle before you actually play, I would recommend removing those lines. So I would just go in and either get rid of them. You can either delete them all or you can put them on a frozen layer. I chose to put them on a frozen layer here. I just called it sketch. And just make sure that it's not on a plotting layer before you send to the printer, or you'll be very, very disappointed, or you'll have a super travel kit assembly required. The last thing we want to do here is etch the edge. So I'm going to put this hatch in. Oh, I'm going to offset actually. We'll offset 1/8. Just going to offset 1/8 inch, and what I want to do is etch the area between the squares and this other line here. So I'll use my hatch command, and I'll show you a quick trick here. All right, I'm going to pick it. All right, I picked my internal point, and it detected that whole boundary there. Now, in order to not get this perimeter cut entirely out, what I need to do is to delete those two lines. And so you see the two lines that I have selected there, they're running around the perimeter of that hatch on either side. But if I delete them right now, oh, it's not going to do it for me this time, is it? Huh, it did it last time. That's funny. Oh, I know what happened. No, I don't. Okay. Sometimes you'll find that it'll fill an entire area if you delete those boundaries. So let me come back here. I'm just going to freeze my hatch for a second. So if I hatch this area in here and pick solid, and then I select this, if I delete it, there we go. You'll notice that the whole area filled in. And if you see this happening, what you want to do is before you delete that boundary, make the hatch non-associative. And that'll dissociate it from those boundaries and leave it as a fixed object, and then you can delete the boundary without the hatch changing on you. Anyway, that's a cool tip or trick for hatch in general. If you don't need to change it, you don't want it to keep moving on you. But particularly helpful if you're setting things up for laser cutting and you need to remove those lines, but need to maintain the hatch in its original design there. Okay. So the last thing that I wanted to note here was just the color setups. So I just gave a quick visual cue as an example of what you could do for color mapping. So you might engrave a raster image. Oh, if you attach a raster image like our profile photos from the very beginning of the presentation, if you attach that to an Autocad drawing, you can print that out. The image frame is detected as a vector cut, so it'll actually cut right around the image. If you're having trouble with it, what you can do is draw another rectangle right around the image in line work just to make sure that it cuts, or maybe it'll make the cut twice. We had some mixed results with that one. But you can assign different settings to different colors and determine and really customize exactly what's happening on the printer side. So with that said, I think I'm going to turn you over to Alex, and he's going to talk about the actual plot settings.
All right, thanks, Victoria. Let me just grab the screen. And you can see my screen? Awesome. All right, so once we've kind of gone through and we've designed our model, or in this case the chess pieces and the chessboard, and we're getting ready to send this over to the laser cutter, doing so is very, very similar to printing to just a regular plotter with some minor differences. Now, depending on the type of machine that you have access to, there's probably going to be proprietary software that comes included with that laser cutter that would need to be installed, and we would want to access that through the PC3 file in Autocad. So, we're not going to go through this in great detail, but essentially you would go through the plotter manager command, and from there you would access the add a plotter wizard and go through the process of creating a PC3 file unique to the laser cutter that you're accessing. So in our case, we were using the Epilogue engraver. And first of all, I just want to apologize. We are bouncing back into PowerPoint because we're not presenting this from downstairs directly next to the Epilogue. There's just way too much noise. I mean, there's a lot of projects going on. So I do want to apologize that we are actually just doing this via PowerPoint presentation. But from here, from the screen, you can see that we have identified the Epilogue PC3 file. And from there, to access its proprietary software, you would go into the properties, right to the right of the PC3 file name. And from there, you would go to the custom settings. And in our case, once we've done that, we gain access to the Epilogger print properties. Now, starting in the upper left corner, we have our resolution. This is really applicable to the raster engraving or image engraving. It'll default to 600 DPI. You can bring that all the way up to 1200 if you really want to get super precise. If you're just doing some quick testing, you could definitely drop that down and not have to take up a huge amount of time. Underneath that, we have center engraving. So what this will do, it'll allow you to define the center of your artwork as the home for the laser itself. So if you wanted to engrave the Boston Bruins logo on a hockey puck, you can center that image on the hockey puck using that option right there. Underneath that, we have the rotary option. We're not going to go into this too much, but there are appendages that you can add to specifically the Epilogue printer. So there are added features that we can do, but we didn't use any of that, so I'll kind of glaze over that. Over to the right of the resolution section, we got this default settings. Now, Epilogue has a variety of different types of laser cutters. We were using a CO2 fed laser cutter, but there are fiber ones as well. We could do an autofocus. The focus would be the separation between the laser head itself and the top of the material that we're either cutting or engraving in. We can define an autofocus based on the thickness of the material, and in our case, we're going to leave it unactive because we want to show you that there is some additional calibration right before we get to the final act of cutting or etching. So we're just going to leave that one blank for now. Underneath that, under job type, we can choose whether we're just doing raster etching or if we're just doing vector cutting or if we're doing a combination of the two. So we can kind of prioritize what it is that we're doing with the specific job we're sending to the laser cutter. Underneath that, we have our essentially our page size. This is something that we don't have to worry about too much from within the Epilog environment because, as Victoria was mentioning before, we had established the limits of our CAD file to represent the extents of the Epilog print space that we had available. So we don't really need to worry about that here, but we can modify that, essentially that print area from within here. Now, over on the right side, we have these raster settings and vector settings. And once we've kind of identified what material we want to be printing on or cutting on, there will be parameters that we need to put in here. So if we have different types of wood, we'd need to kind of play around with these parameters. If we were doing acrylic, that's another type of material, so we'd have to be conscious of what these settings are. Now, the good thing is most manufacturers have figured this out for us already. And in our case, being down in the build space, we were able to collaborate with a lot of the people down there that gave us these recommended values. But essentially, the three values that we need to be worried about are the speed. So that is the speed of the laser head as it's moving back and forth, making its cuts or engravings. The next is the power. So the power is kind of, it controls the depth of the cut. The analogy I like to think if one's not very familiar with these terms is picture yourself on a sandy beach. And you got these little waves that are kind of lapping on the shore. They're really not going to be taking a lot of that sand away from the beach. There's not a whole lot of erosion going on. That would be representative of a low power setting. Alternatively, say there's like a hurricane out in the ocean. We got these 10-foot waves coming crashing on our beach. I mean, that's going to cause a huge amount of erosion. So we could say that that's a lot of power in the laser. So these parameters, they vary between 1 and 100%, and again, would depend on the material. The last one we're worried about is frequency. And frequency basically is the heat of the laser. How often are we sending a pulse into the material that we're trying to engrave in or cut in? So both the power and the frequency go hand in hand and play a lot in with how deep into the material that we're cutting. You'll notice that for the raster settings, the frequency option is grayed out. That's because it's not something that we're really worried about when we're doing the raster etching, but it is important for the vector cutting. Over down in the bottom, you'll see that there are these two boxes, speed comp and power comp. The speed comp is essentially to kind of kick the laser into half speed. So say we're doing some etching and we realize, wow, things are kind of like moving way out of control. Let's try to test things out a little bit slower. We have the option of selecting that speed comp. And the power comp is essentially it drops the power down, which is good for if you're doing a lot of curvature work. So if it's very detailed and it's not very linear type cuts that we're doing, we're curving in our material, we can drop the power of the laser down so that we get a nice clean cut. So that was the general tab. If you notice at the top, we've kind of cycled over into the advanced tab. Gonna just glaze over this. This is really for if you're doing like rubber stamp work. There's a little bit more work involved when you're creating those rubber stamps, but in our example, we're not using that, so we're just going to skip over that. And then the last tab is the color mapping, and we can use this if we want to get really fancy in our AutoCAD designs. And as Victoria had mentioned, we can assign different colors in CAD to have different types of cuts or engraves in the Epilog laser cutter. So here everything is controlled very similarly to as we would control it in CAD. We have our red, green, blue primary colors that are the same numbers that we would assign in CAD, so we can, even if we weren't using one of the primary colors, we can be very specific with the color combinations that we're assigning in CAD and have that represented with speed, power, and frequency here in the Epilog, and really gain a lot of control on what it is that we are either cutting or engraving on. We can make things deeper cuts based on color or shallower, and again, a whole lot of flexibility can be applied to our design, and that would be controlled a lot through the color mapping. So once we've figured out everything we want in terms of speed, power, frequency, and our color mapping, we would OK out of this, and then come back to our CAD environment that we're very familiar with. Now, we did some trial and error. We did notice that, with this Epilog printer, or cutter, sorry, the order of operations was actually quite critical. The Epilog was really good at kind of throwing these little quirks at us and resetting, the scale or the extents. So we found that it was really important to go through this order of operations where we first established the properties in the Epilog. And then under page size, we selected something reasonable to represent our print environment. And then we noticed that under the plot area, we were getting really consistent results if we actually did a plot by window. Right now it's shown as display, but if you're familiar with this, if you just selected a window for your plot, then you would just see what you select there. But we discovered that that was really helpful for consistency's sake. And the other thing is that the Epilog really liked to automatically rescale what it is we were trying to cut or engrave. So finally, we made sure that we were doing a one-to-one scale so that we were accurately representing what we were designing in CAD. And again, the scale was super important because if you remember what Victoria was saying, the size of that notch needs to be equal to the thickness of the material that we're using for the laser cutter. So if it's scaled down or scaled up, that notching is not going to be as precise as we want it to be. So once we got that done, we hit the preview, make sure everything looked good, and then we hit OK. So we're getting closer. We're getting closer to actually doing some laser cutting and engraving. So once we hit OK in AutoCAD, we essentially send all of that information over to our Epilog. And this is a picture of the actual tool that we have downstairs in the build space here in Boston. You can see we have a pretty decent size bed on which we can do our work on. And the one thing I do want to notice, and did kind of throw us for a loop the first couple of tests that we did, was you'll notice that our cutting board is located way up in that upper left corner, but CAD isn't oriented the same way. CAD is thinking 0, 0 is in the bottom left, but in the Epilog world, 0, 0 is in the upper left. So we had to make sure that we were orienting ourselves in the right position. And one thing we did find was we were doing a lot of testing. As we were learning this for the first time and as we were getting comfortable using this and setting the parameters, we were going through a lot of material. And that was a great thing, actually, about using the laser cutter and its flexibility in different materials. One of the build space guys downstairs said, hey, you don't need to be using all of your material. Just use a piece of cardboard. So we're like, oh, all right, well, grab the piece of cardboard, relatively inexpensive material, and we did all of our testing on the cardboard, which was fantastic. So we, the time that we were sinking and wasting material was done on something inexpensive rather than the actual, high quality wood that we had purchased.
Yeah, those we actually ended up with a really cool cardboard set of these chess pieces too. So that was an unexpected surprise.
Exactly. So again, testing kind of resulted in these pretty cool byproducts. All right, so we're getting closer. We sent the information from AutoCAD to the Epilog. Not quite there yet. So kind of just taking a little sidestep here, once it's sent over to the epilogue, everything is kind of controlled through this one very simple interface on the epilogue. We have a couple of options here. We got the job, the focus, the jog, the speed, the power. Don't really need to worry about too much about this, other than we do need to do some calibration. So we need to focus the distance between the laser cutter and the top of the material. So we do need to worry about that. So this is kind of like a zoom up of the laser itself, and in this case we have an acrylic material. We opted to use acrylic for the board, and you'll see some examples of what that looked like later. Had a pretty cool effect. But you'll notice that triangular piece on the laser head itself, and that's the tool that we use to calibrate the distance between the laser emission point and the top of the material. So there is, again, some additional calibration that we need to do physically on the machine before we can actually go ahead and print. This is the end result. This is our chess board, or not chess board, but our chess pieces on the board that we cut them out of. And you could see that we have all of the cutout pieces, and they're essentially reciprocal on the board itself. And you can see that it's very, very clean. The level of detail was remarkable, and you can really see that in the cross of the king piece. We were a little concerned, like, geez, is this thing too small? Is it going to break off? We really were kind of nervous. But, I mean, the resolution capabilities of the laser cutter was fabulous. There were some things that we did note that, you will see some staining of the wood. It did get pretty hot, so maybe we could have played around a little bit more with the power and the frequency settings. But there was some interesting results for our first cut here.
Yeah, and it's interesting too. We used it was either a laminated board or some kind of composite, and the glue from it actually made the edges of it sticky, and that went away with time, but that also contributed to the residue on the board. I think if we used a solid wood instead of a laminate, it would have come out a little bit differently depending on which material you're using.
Exactly, and again, I think that would play into the, trying to test different materials to see what the results are going to be, because you can't always necessarily predict what your end result is going to be. So, but again, it worked out really, really well, and you can see in the upper left we have a couple of our pieces that were cut out, and you can see what those look like. And here, this is me and one of our build space representatives kind of taking our first piece out of that board. And on the table, you can actually see some already assembled pieces, and those were actually our tests using the cardboard. So as we were kind of testing things out, we were kind of already creating these cool models and being able to get a sense of what that design was actually going to look like in the tangible materials that we were using. So as I mentioned before, there was some trial and error, and it's only fair to show you guys some of our not so good results. These are using different materials. We tried etching things out in cardboard, in wood, in acrylic, and one of the references that we found had suggested to use like an alcohol solution to clean up the acrylic to kind of make the engraving show a little bit cleaner. But in our case, we inadvertently cracked the acrylic.
Yeah, it did not take very long to crack it either. the acrylic makes a lot of dust and residue when it prints, and so it gets everywhere. So you have to rinse it under some water, and the alcohol was supposed to clear it up a little bit, and I think I left it on there a little bit too long. If you're looking at that kind of artistic effect, though, that's something interesting to note, because Nauman's actually looks pretty cool. One of the other weird things about the acrylic is that you want to be viewing it from the opposite side that it's etched on, so you actually have to flip the image. So you'll notice that Nauman and my pictures there are backwards when you're looking at them from the correct direction. You can tell by his logo there, it's all backwards there. But I don't know, some of them came out, even the mistakes came out looking interesting, in my opinion anyway.
Yeah, and even our test, you can see a little bit clearer down at the bottom there. We have our cardboard test, and I was so amazed that even the cross on the cardboard came out. I mean, that was just fantastic. I mean, it's on the order of only like a few microns, it seems, and it just cut it right out of the somewhat malleable cardboard material. The other thing I wanted to point out is towards the center, you'll see that the epilogue was kind of throwing us curveballs and kept wanting to rescale the cuts or engravings. And so you can kind of see one of our super miniature attempts at creating our chess piece, which would obviously not work because they're way too small, and so the notches aren't actually going to be representative of the thickness of the material that we used. But here we go. Here's a close-up of our success. You know, we got this eventually to work. Here we have a couple of our pieces, and you know, the king on the side, you could kind of see how they're sliding into each other, and once you slide it into its fullest extent, they stand up and they're pretty solid. And the cool thing is we still have the reciprocal of these cutouts on our board. So say you wanted like a travel chess piece, you could just disassemble all these, fit them back in the board, and off you go. So we thought it was a pretty cool concept. And here we go. We have all of our wood chess pieces assembled on our acrylic board, and you can see how the hatches that we assigned to those white pieces are kind of scored, and it gives it that kind of white frosted effect, whereas the black squares that we had, or well, essentially the empty squares that we had in CAD, are untouched and are completely transparent. And so here, finally, we have our two sets. We have our 3D printed set, where we started off a few months back doing some 3D printing, and they are playing against our laser cut wood pieces right on our board. We thought it was pretty cool. And again, the cool thing about this is that, you know, the LT users out there still have the ability to go from that digital to the tangible.
We just got a comment in saying, apparently we are right in time for the World Championships for chess in New York City. So that's pretty cool. I had no idea. That's awesome.
Or maybe it was by design. No. Very lucky. Very cool too. All right. So that pretty much wraps up our webinar on the laser cutting. So you guys will have access to this. We got some additional resources for you guys. You know, some information on Print Studio, some more information on the build space here in Boston, a link to the Instructables laser cutting basics, and Pinocchio. Again, if you don't have a laser cutter in your basement, you know, there are methods for you to go ahead and do this. So thank you for joining us. We always appreciate your feedback.